Happy Groundhog's Day. I'm thankful that I think winter is not going to be elongated, which is good. Anyway, so this talk is, as she mentioned, how good C# habits can encourage bad JavaScript habits. This talk came from an architecture review I did for a client on their front end, and it was obvious that the developers had C# backgrounds, and they were picking up JavaScript on the job. And so they made a lot of the typical mistakes that I've made and that other people make as well, who don't actually take adequate time to learn JavaScript appropriately. And really the biggest challenge is JavaScript looks so similar to C#, but when it comes down to it, it's more of a functional language, kind of like F#. And so there's some really big differences. And so we're going to take a look at that. So can everyone see the first screen? Take that as yes, good. So again, I'm Elijah Manor. If later you want to come to my blog, it's elijahmanor.com. I'm on Twitter, Elijah Manor, and elijah.manor@gmail. If you want to contact me. So this presentation is based on a series of 3 articles that I wrote on enterprisejQuery.com, which is hosted by Pintu, which is where I work. And so if you want to go back at a later time, either watch this webcast again, or you could actually go to the articles and read the text associated with the code snippets. The first point we're going to talk about is not understanding falsy values. So if you're used to C#, I mean, you got a Boolean, true or false, and if you have an if statement, that's something evaluates to a Boolean. JavaScript, it's sort of like if you ever did C or C++, a 0 could actually be true, or a 0 would be false, so 1 would be true. JavaScript goes even further. There's something called falsy values, and let's look at these real quick. Any of these values would, if it was an if statement, would be false essentially. So false is a Boolean, so that's understandable. A null would be considered falsy. Undefined, JavaScript, you don't have to declare your variables, so something actually could be undefined, has no value. An empty string, which kind of confuses a lot of people. If you were to evaluate it, it would be false. And a 0, kind of like C, and then there's not a number. So anything that isn't these things would be true. So just an empty object would be true. And really, the next several points kind of piggyback off this concept. And so it's quite different when you actually deal with if statements and logical logic. So the next part we'll go to piggybacks off the falsy value. It's not testing and setting default values correctly. What you might be used to in C#, because no one wants to have like object reference null error, because that happens a lot. So it's common to always do not equals, like your variable not equals null, and then you usually test that it has a length before you actually do something. And that's become so common that the .NET framework has a is null or empty method off the string. And then even in the most recent framework, I think there's a is null or empty or white space, which make sure there's not spaces or tabs. So that's a very common thing to do. And what you'll see, C# developers writing JavaScript will write similar code, but it's not necessary because of falsy values. And so what you'll actually see, writers of JavaScript frameworks and people who know about falsy values, they just test for the variable. And so what this does, behind the scenes, it tests if it's null, if it's undefined, make sure it has a value, because if you remember, empty string is false, is a falsy value. And so just by doing this, tests for all those cases. So this is some more common code you might see for someone who understands falsy values. The next thing is setting default values. In C#, you might test something for null, or that it has a length of 0, and you would set a value. You might see a ternary operator that technique, and it's become kind of common. So in C#, there's actually the double equal or the double question mark, the null coalescing operator. Obviously, that doesn't exist in JavaScript, but to basically do that same thing in JavaScript, because of falsy values, just like we talked before, this is what you'll see in like JavaScript frameworks like jQuery and Dojo. And if you actually look in there and see how they do things, they test for a variable, and if it's null or undefined or all those falsy values that we talked about, then that returns false. So it would instead, based on a logical OR statement, it would use this value instead. So if this had nothing in it, well, then it's going to evaluate default value and then store that back into the original variable. So that's a technique that you'll see more commonly. Now, if you have, there might be an example where you want to only test for null, and in this case, this tests a lot more than that. It tests against all the falsy values. So just keep aware. But this is something you'll see often when you look at other people's code. And so really the best practice out of all this is understand falsy values. And there's only like those 5 or 6, and everything else is true. So as long as you understand that, your code could be a lot cleaner. And when someone looks at it, they go, oh, he understands what's going on. The next really easy thing to spot in JavaScript code is C# developers using the wrong comparison operator. So for example, this is a very bad habit, is to use the double equals or the not equals, which, what? That's what you use all the time in C#. Well, as it turns out, in JavaScript, you can get in some really crazy scenarios if you use the double equals or not equals. And this is partly because of the falsy values. And what it does, the double equals, it will try to do the best it can to figure out and coerce each side of the double equals to figure out, is this false or true? And so it uses those falsy comparisons that we talked about. But what you get is some really crazy results. Like, for example, all these statements evaluate to true. So 0 equals empty string, that's true. It's like, well, I wouldn't have thought of that necessarily. Or 0 equals, tab and character return. You're like, that's crazy. What a crazy language JavaScript is. And it gets some bad reps because people are using these operators. So what you should do instead, JavaScript has a triple equals and a not double equals. And what this does is called the identity operator. And it basically, it doesn't try to coerce each side. It just takes it as is. It says, okay, is this equal to that? No. Is this equal to that? No. It doesn't try to mess with the left or the right side of the operator. This is what it is, and I'm going to use it. So an easy takeaway is to always use the triple equals and not double equals. There are some cases where you could get away with the double equals, but I would just suggest don't do it. Just because you're going to get in some confusing code and you're going to blame JavaScript, whereas you could use these and it would make sense. The next point is not declaring arrays and objects correctly. So what you'll see, because C# developers are so used to object-oriented languages that they'll always new up an object, and there is a new object you could create and a new array. These were really added later in the JavaScript lifecycle when it was being created, and it was kind of to appease Java developers, just because they were so used to the syntax. But there are some native ways to do the same thing. This is not wrong per se. It's just there's a couple extra steps it's doing that's not necessary. So really the preferred way, and it's a little more flexible, and I'll show you an example here in a minute. The preferred way, if you want to create a new object, just say person and then use the curly braces. And then if you want an array, just say keys and the bracket syntax. And what that gives you, it's kind of nice because similar in C# where there's the initializers that you could do if you want to create an object. This is called an object literal. And so I'm creating a new object, and I could immediately set its properties, its first name and last name. I could set some functions off of it immediately, and so right after this statement right here, I have a full working object that I could play with. And same with keys. Instead of using the new array and then on a separate statement, you have to like build it up. You could initialize it really easy in this type of method using the brackets. And so this is what you'll see if you dug into libraries like jQuery and stuff. Like that's how they actually do stuff. Now the other way is not wrong, but it's just not preferred. And so really the best practice is to use the literal notation of both of them and reserve the new keyword for some of the standard things that JavaScript has, like I guess date. But for Boolean, you don't need to do that. You just say true or false, stuff like that. Reserve the new keyword for custom constructors that you have. We'll briefly touch on that a little bit later, but the next common mistake that I see is not using the for in statement correctly. Most C sharps, they do a for each statement all the time, and they're so used to it, and then they see that JavaScript has something similar. It's a for in, and so they're like, oh great, I'm gonna do this. But the problem is you should not use it on just standard arrays. It's more meant for something else that we'll get to in a second. So here's a problem that you might run into if you used it on arrays. So we're going to create a new array, just an empty one, using the literal syntax that we talked about. We're going to immediately set the index of 5 to the value of test. Now, one thing, you just have to get used to this. By setting the index of 5, if you asked the array what length it is, it would say it's a length of 6, even though there's only one value in it. That's just something you need to know. Indexes 1 through 4 would be undefined, and that's just kind of the way it works. And so a typical C# developer would come and say, oh, I want to do a for in over this array, and what they might expect is it to go, index 0, index 1, index 2, index 3, index 4, index 5, and print out a bunch of stuff. Well, the for in is only going to print out one thing because you only put one thing in it. And so that might not be what you expected. So the preferred way is for normal arrays, use the standard for loop that you're probably used to, setting it to index variable to 0 and going to the length and incrementing it. And that will give you probably what you expect. And keep in mind that the indexes lower are going to be undefined because you haven't set them yet. So what you there's another caveat. We'll actually get to that a little bit. No, we'll talk about it now. What the for in statement really does is it iterates over the properties of something, and so we won't go into this too deeply, but there's something called a prototype in JavaScript, and you could kind of think of that as sort of inheriting values from like a base object, if you're familiar with that in C#. So what will happen is if anyone adds something to this kind of base object, the for in will pick it up. And so let's say someone in a script far away adds a prototype to array. Well, if you start looping over one of your arrays, it will pick up whatever variables or things that they added to that. So that could be very unexpected. So anyway, really the best practice is for arrays, just use the standard for statement. And then, what we want to do is use the for in statement for objects. But you could still have the same problem of the prototype bleeding through. So if someone modifies the array with additional properties or functions, you'll have a problem. So the way to solve that, this looks a little hokey. So here's the for in. And so this is the object that you have. Let's say this is a person. This is Elijah that has first name, middle name. This name would actually be the key that's on the object. So you have a key value pair. So key would be first name, the value would be Elijah. But what you have to do, if you don't want to actually iterate over the things that are inherited from the prototype, you have to say has own property. And so does Elijah have his own property of first name? If it does, then print it out. And when it goes to hit the prototype, whatever they added, this will be false and it won't execute your code. We'll take a look at a real world, well, it's not a real world example, but an example that kind of shows the difference. So here, and this is a best practice, actually shows worst and best. We're going to define a person constructor, and the standard is to capitalize the P so the developer knows to new up this. And this is called a constructor, similar to sort of maybe a class as you might in your background. So you pass it a first name, last name, it builds up an object. And what we're going to do is we're going to add a prototype to this constructor and add some additional information. So are they married or do they have kids? So what we're going to do is new up two people, John Smith and Linda Davis. So we're just going to new up two people. And we're going to just say John's married. And so now we're going to use the for in, just standard vanilla over John. What it does, it prints out his first name and last name, but then it also picks up is married and has kids, which you may or may not want. Like this, you actually may have wanted this thing, but it possibly could confuse you if you don't understand that the prototype had something added to it. So the appropriate way is to check for the has own property in the if statement, and then it will only print first name and last name, which are the properties that were actually in the constructor initially. And it won't pick up the prototype ones. So it's kind of a lot to say, but really it boils down to two things. Use the standard for statement on arrays, and use for in on objects, and remember to check for the has own property. And at the end of this presentation, we'll actually discuss a tool that will identify most of these problems. And so, because you might be saying, okay, I can't remember all that. Well, there's actually a tool to help pinpoint these things for you, and I'll show that in a second. The next, and this is actually a big thing, is misunderstanding scope in JavaScript. As a C# developer, you understand block level scope. So anytime you see a curly brace, that's a scope. So any variables in there is enclosed in that scope, and that's just what you're used to. And other languages like Java and C and C++ all do the same thing. Unfortunately, JavaScript is different, and this could lead to very confusing scenarios if you don't understand it, which I think is another reason JavaScript gets a bad rap, because you get into some crazy code and you're like, I don't understand it, but hopefully we'll reveal some of the magic. And so let's look at this code, which is, I call it bad code. And so let's look at it real quick. We have an eat function with some variables, food and hungry, and we're testing if they're hungry, and then we declare a variable inside of this if statement. Now in C#, you would think that between these braces, that time to wait would be isolated to that scope, but that's not the case. What the scope in JavaScript is functional level. So this function is going to share the same scope all the way down to the bottom. So we're going to have a sub-function here that could actually access time to wait. It could use time to wait because it was declared. Oops, sorry, I missed. My slides got all messed up. So anyway, that's this shows someone who doesn't quite understand where the variables are declared. We could actually get into some problems. Oh, actually, sorry. The best practice to do is anytime you have a function, and we'll get into this more later when we explain what's going on, but when you have a function, try to declare all your variables at the top. And that way, it's obvious that all these variables can be shared across all functions and all if statements, and they won't be confused as much. So it's considered best practice to always declare your variables at the top of a function. If you've ever done VB coding, like VB6, or I'm not sure if this is the best case in VB.NET, but when I did VB6 back in the day, it was considered best practice to declare all my variables at the top of a function. And and it's considered the same thing in JavaScript. Now in C#, typically I've been taught, don't declare a variable until the last minute, like when you need it. Uh, but that's not the case here, and you could actually get into some really crazy things, and we'll show some of those if you don't follow those principles. And the principle that I'm talking about is variable and function hoisting. So what JavaScript does behind the scenes is, let's take a look at this piece of code, which looks harmless, and it actually is harmless. There's a say hello function. We pass it first name, middle name, last name. And then we concaten the whole name together, which is fine. And then we test, is the name Carlos Ray Norris, which for those of you who don't know is Chuck Norris. That's his full name. So inside the if statement, we have another var. And as we talked about, that's not considered best practice. We want to try to declare them all at the top. And so it's going to print out, hello, Chuck Norris. And but behind the scenes, if you wrote the code that way, JavaScript really took that variable that you declared and it hoisted the declaration to the very top of the function, so way up here. So it hoists all variables to the top of the function, like the main function. It sets them to undefined, and then it keeps the assignment wherever you had it. So whereas the previous case, we had a var here and here. What JavaScript actually looks at it shoves all the vars up to the top and then just keeps the assignment where they were. Now, in this trivial example, the output is the same, but consider this example. You have a nested for statements, and you have the same variable, I here and I here. Now, the developer might have thought this would say hello 50 times, but in reality, what it does, the var, the I variable, was hoisted to the very top, so up here, and they're both reusing the same variable. Because even though you said var twice, there's only one, it's the same scope. So basically this statement keeps overriding I, and so it's an infinite loop. Now you can't actually do this in C#. They have actually protected you against this. But in C, raw C code, this would run fine. And so that's a scenario to understand. Here's something that's some code that actually could exist. Let's try to figure this out. This deals with hoisting as well. So there's something called global variables. You might have heard it. We'll talk a little bit later about how to minimize those. But a global variable is if you don't declare something, or you declare something at the most outer level, it's considered global, and like anything could access it. So what we're going to do here is we're going to log some variable, and it's undefined. And you're like, oh yeah, well that makes sense. I haven't declared it anywhere. That should be undefined. And now we're going to create a global variable. We're going to declare it and give it a value. So that makes sense. And then we're going to log it, and it equals what we just set. Hunky-dory, that's good. We understand it. So let's assume someone called this function. We're going to log out some variable. And what we find in this particular case, and we'll see in a second, it's the value's undefined. And you might say, well, wait a second, I thought I'm just trying to print out the global variable that we set up here, and it seemed to work. Why am I not seeing the value 42? And so you go, okay, well, let me assign the global variable 1, and then print it out. Like, oh, good, it's 1. Things are starting to make sense again. But then you print out the global variable. You could actually force it to all global variables are accessible off the window. And so you print out Windows some variable, expecting it to be 1, because that's what you thought you were doing. But you get 42, and you're like, well, that's confusing. I thought I just set the global variable to 1 here. So the bug in this whole piece of code is somewhere deep down inside this function, there was an if statement, and someone used the var, tried to declare a new variable called some variable. So what this did is now some variable, it's local to this function. It's the same name, but now it's going to use the local one instead of the global one. So what this did behind the scenes is JavaScript hoisted the variable. So it took the declaration, shoved it at the very top of this function, So it declared, and let's look to see what it did. So it took that variable inside the var. It kept the assignment here, but it shoved the declaration to the first thing under the function and set it to undefined, because that's what it always does. It moves the declaration, sets it undefined. So that's why when we tried to console it, it was undefined. It wasn't referencing the global one. It was referencing a local variable to that function scope. And so if you had code like this, this could be like several days worth of debugging, trying to figure out why in the world it's not working. And again, you would blame the language just because of the concept of hoisting. So again, to get around that whole problem, if we had just declared everything at the top of the function anyway, they would have worked just fine. And that's because that's what JavaScript does behind the scenes anyway. So if you just conform to what it's going to do anyway, things work out nicely. Unfortunately, function hoisting has some separate rules. And so let's take a look at that. There's actually two ways to declare a function. You might be more familiar with this one, where you actually say function, space, a name, and then do something. That's called a function statement, because the statement begins with a function. The other way to do it is to declare a variable and set it to a function. Really, they act the same way, and really, behind the scenes, a function statement gets converted into a function expression. So that's just a little knowledge. So let's look through this example and see if you might have run into this scenario. Okay, so we have two functions to find below. One say hello, one say goodbye. We immediately try to call say hello, and we get an error. We're like, oh, well, okay, that sort of makes sense. I haven't defined the function yet. Trying to make sense to yourself. And then you say goodbye. But that works. And you're like, okay, well, if say hello doesn't work, then I would expect say goodbye doesn't work, because I didn't declare either of them at the top. I declared them down here. So this is the difference. The function expression behaves almost the same way as the variable hoisting, because actually it is a variable like this. So it will hoist the variable to the top, set it to undefined, and keep the declaration of the function where it was. And so when you say hello, it's set to undefined, so it blows up. There's a special rule with function statements, like this one. It will actually hoist both the declaration and the assignment to the very top. So that's why we were able to call it here, and it would work. So let's see how it might look the way JavaScript interprets it. So it hoisted both of the variables to the top, but it also hoisted the actual assignment of the goodbye function to the top as well. And so that's why you were able to, when you called say goodbye here, it worked, because the assignment was above it. So really, most of these cases that I mentioned, as long as you're in a good practice of assigning your variables at the top of your function, you should be fine. And it would be good to understand the function statement, how that's a little bit different, if you need that to work. The next point is not using closures correctly or even at all. You possibly could have this problem in C# if you're using some of the functional nature of the language. But you'll see this problem kind of a lot in, like, if you're doing jQuery and DOM type stuff. So let's look at this example. So I'm using a little bit of jQuery here, but not a lot. I'll explain what I'm doing. I'm selecting an unordered list that's presumably empty, and then I have a for statement that I'm looping over 10 times. In each iteration, I create a new list item, and then I use the initializer of jQuery to set the ID to the index, so it'd be ID of 0 through 9, and give the text, so the link 0, link 1, link 2, link 3, and then I'm assigning a event handler to the list item. So if I were to click it, I would expect, the developer would expect to say, you've clicked 0, you've clicked 1, you've clicked 2, you've clicked 3. But what really happens, and let's see if I could get this, actually, see if this will work. Yeah, so here's the output. But what happens is if I click any of them, I get the same result. It says you've clicked 10, you've clicked 10, you've clicked 10, you've clicked 10. Because what it's actually doing is this click handler, it's not storing the value at the point of time that you're setting it up. Once the event handler is actually clicked, at that point it would be 10 because it's still in memory and it's just going to reuse that. So what you intended is what you wanted to do is to print out the variable at the point of time which you set the click event. And so how we can do that with a closure. And closures are slightly confusing, and if you don't quite understand it after this brief description, that's okay, because for many people it takes numerous times to see it and play with it. But this is an example from Mozilla. And so what a closure is, it's a special type of object that combines basically the environment of which it was created. So a function object actually has a special property that you can't access it, but it's a scope property, and it can remember the value of the variables at which point it was created. And so let's take a look at a little example, kind of a silly one, but this is a make adder function, and you pass it a value, and inside of it, it returns a function, which looks kind of odd if you're not used to it. But the function it returns will take the initial value that you gave it, it stores it internally, and then when you call it again, it will use it and add it to whatever you pass to it. So let's, for example, we'll call make adder. We'll pass in a 5, which it remembers that value inside this function. So it's closed around the value 5, and then in the next one we're going to make an adder. We pass it a 10. It's going to remember close, a scope around the value 10. So when you actually call it and pass in a value, it will take 2 and add it to what it was closed over. So 5 plus 2 is 7. And then the same thing with a 10. The one we created for 10, it will add it with 2 and give you 12. Interesting concept. I tried to diagram this. I don't know if it will make a lot of sense to you, but in the global scope, we have 3 variables: make adder, and add 5 and add 10, which were created using the adder. Add 5, if we look at it, points to an object because we returned a function from the make adder. And so internally, it returns x plus y. But it remembers, it has an internal scope. It says, okay, at the point I was created, I had a scope that had x with a value of 5. And so anytime you call this function, it will remember the value x and add it to it. And so that's sort of a way to visualize what a closure is. So a way to fix the previous example is to create a closure. And so in our click handler, instead of just consoling it, we will return a function. And what we're going to do, we're going to pass in the index that we wanted, which will come through this function, and it will be remembered. And so it will enclose itself around that number, and when it goes to be called, it will look at its scope variable and say, oh, this is defined, and I'm going to use it. So if we were to run it, it's a little flaky. If we were to run it, we would get the appropriate index anytime you click it. We can make the code look a little bit maybe less crazy if we split out the function externally. we're still returning a function, we're still doing everything else, but when you're building it up, it looks a little more sane. Either way works fine. So closures are kind of a complicated topic, and if you didn't quite understand it, that's okay. There's many resources to talk about it, but you need to be aware that if you have a problem that kind of looks like this, maybe you need a closure. The last section, which is kind of sort of large because I'm going to show numerous ways to handle it, is having variables and functions in your global scope. It's considered bad practice to have a bunch of things in the global scope because it can conflict with other libraries or even your own libraries, like variables. The intention is to namespace your things, which you're probably used to with C# because you don't want a clashing of your function names or variable names. And it's even bigger than just what you're using. If you think about it with Google Chrome or Firefox, all the plugins and extensions you download, they're actually running their JavaScript on your page as well. And so you could conflict with global variables that they declared by mistake or they didn't realize. And so if you're not namespacing your stuff correctly, you could get into some weird cases, and it could look really random, like maybe because they had a plugin. And I've actually seen that with certain websites. Things have broken, and then I've told the developer, and they're like, oh. And then I disabled all my plugins and had to put them one by one, and I found which one broke it, and yeah, crazy stuff. So what you'll see, and this is a bad habit, is just to use a bunch of global variables. And so var at the top, that's global. Actually not declaring something, we'll still declare it, and that's bad. Even with functions, I've seen libraries that just name a function and rock on. Well, you could actually call that off the window object. It's global. I mean, there's nothing protecting it. So the way you'll see some people is they'll prepend some name to the function, thinking, well, it's less likely that someone will use, my namespace, like DevExpress, whatever underscore function, because all of these techniques, are polluting the global namespace. Anyone could call them from any library. You could clash. It's dangerous, and it's not really a good way to handle it. I'm going to show you 4 different ways to make it better, and in sort of progression of difficulty, but the further we go on, there's more benefits. The easiest one is just to use an object literal. We kind of talked about this before when I created a person with first name, Elijah, last name, and then a function. But I'm just creating a new object here using the curly braces that we talked about. And I'm giving it a property and a function, or a method. And these are going to be public. And so the skillet, the variable that we're assigning it to, you can kind of think of that as your namespace. And so I'll call a skillet fry, and then I'm frying something. And then I can change the quantity. And everything on this is public. There's no private or protected things to do with this. The cool thing also, once you have your namespace or your variable, you could add properties and functions later after the fact, just dynamically, and you could call them, and that's great. This is probably the easiest way to make sure you only have one global object, because all these examples only uses this one variable, and so that's good. We're not polluting things. So the pros are you're cleaning up the namespace. The cons is everything's public, and also the syntax is a little funky. Like you got colons here and commas here. It looks similar to JSON if you're familiar with that, but it's not technically JSON. They're slightly different concepts. So another approach is to make everything private, and to do that, we introduce an interesting concept called the self-executing anonymous function. That's a mouthful, but what it really is, if you look at it, is you declare a function that has no name, and then after you declare it, you just immediately call it. And so there's no name, and you call it immediately. So what that gives you is there's no way to access this once it's executed. So everything's private inside of it. So this variable's private, this function's private. You could call it inside of it, and it will still run. But after, once it gets to this line right here, where my cursor is, there's no way to get back to it. I don't see this a lot occasionally, but this is a way to make everything private, which is the complete opposite of the previous one. So even if we tried to grab the ingredient off the window, well, it's not to be found. There's no function for fry. There's just not a way to get to it. Yeah, so the pro is it definitely clears up the global namespace to the fact that there's nothing on the global namespace. It runs only once, which you possibly could have wanted. The syntax is nicer. We don't have those colons and things. We have the normal things we expect, like equals and semicolons and things like that. So it looks a little bit cleaner. But everything's private, so that's kind of a con. And it's a little bit more complicated. I guess you could consider that a con. The revealing module pattern is a nice in between. It gives you public and private. And this uses the similar concept of a closure that we kind of touched on. It still uses the anonymous function that's executed, but what it does at the very end, it will return an object. And I called it pub to kind of symbolize that anything off of that object's public. So the trick is you declare an object, and anything you attach to that, like ingredient and pub, those will be public things that you could call later. But things that you don't attach to pub, like you just declare a function or you just declare a variable, those will be private. And only the things inside of this, only these public things or private things can access this private property. So that's good, and it's a great way to go. So we could still print out the ingredients, and we could call the methods. We could even we could add new public things to it, and we could add new public functions onto that. But what we can't do is create a public function and attempt to access something that was private. So there's no way to get at this, even if we try to add a function and make it access it, there's not an easy way to get at that. So so that's good, and that's probably what you would expect. So again, this allows for public and private. That's a great thing. Once you understand the anonymous function that's executed, it's not too bad to understand. The code looks good. It doesn't use the weird, JSON-ish type syntax. But the con is there's no way to add private properties or private functions, which you may or may not want to do. Now this last one, and this is our last point, is to use the self-executing anonymous function, but to do it by actually passing in some parameters. Before, it was just empty paren. We just called it immediately, didn't pass anything. So the trick for this one is it's going to have these parameters. The skillet, we're actually going to pass jQuery into it, and we're going to have undefined. And that's kind of a trick. We'll show that in a second. When we call it, like I said before, this was always open paren imparen, but now we're going to pass some things. We're going to pass the skillet, which is our namespace. But what we do here is we check, has the skillet ever been created? And this is used the falsy values we talked about at the beginning. And if the answer is no, it will initialize it using the double equals, which we talked about, with an empty object. But let's say this was the second time this was called. Well, it will say, is there a skillet? Yes, there is. Okay, just use that skillet again and pass in the skillet. So this is a way to possibly grow a library over multiple JavaScript files. And then we pass in jQuery because we want to be a good citizen, because other libraries use the $ as well. And so we'll pass in the full name jQuery, and we'll refer it to the $ because most people like to use the $. So inside our function, we can use the $ and know that this is local to me, and it's not going to conflict with any other library. It's just kind of a good thing to do. The last thing you'll notice is we're not passing a third parameter, but we have an argument up here. The reason we did this, or the reason for this, is undefined is unfortunately not a reserved word in JavaScript. And as you remember, undefined is a falsy value. So that could be problematic. So some really bad person or someone by accident could redefine undefined to true, which would screw up all your code. And so what this does is if you pass any, if there's no argument passed to this function for the third argument, it will always default its value to undefined. And so by having this third one and not passing one, undefined is always guaranteed to have the value undefined. So any code inside of our function that uses tests against undefined will respond accordingly. So that's a little trick that might have been confusing because it's saying the word undefined a lot. But if we look inside this function, it's all the same types of things that we saw before. We're adding anything we add to the skillet that we passed in will be public, kind of like the pub that we showed before. Anything that's not added to the skillet, like these properties and functions, will remain private. And but the cool thing is we could use that same technique over again to build up our library. So now we're going to have, we're adding a public method to the skillet, but we also could add private properties as well. And so the previous technique didn't allow us to add private things after the fact, but this one does. And so this is a common technique you'll see different JavaScript libraries use to build up, like if they have components in their JavaScript, that's how they kind of build them up. So this has the most pros. Public-private, the code looks normal, no weird syntax. It protects jQuery with conflicting other libraries. It protects the undefined from getting reset, and it allows you to build up libraries together. So yeah, so the main point is to minimize globals, to the variables or functions in the global scope. And the easiest way is to use the object literal. I wouldn't say there's a catch-all, always use one. It's really what's best for your project and what you're doing. But you kind of want to consider that because you could get some crazy situations. So the tool I mentioned, and this is really quick, I'm going to grab all the bad code, not all the bad, a lot of the bad code that I showed in this presentation. And if you go to jslint.com and run it, it will, Douglas Crockford built this. He's the one who came up with the JSON language. This will actually identify most of the problems that we've talked about. For example, it says, oh, well, you should use the not double equals instead of the not equals. You should use the triple equals instead of the double equals. Consider using the object literal notation, curly Qs, instead of saying new object. Use the literal notation for the array instead of saying new array. When I'm using the for in on an array, it's like, oh, you should probably check the has own property inside of it. And then it's like, oh, we got a global variable here, and then yeah, a bunch of other stuff. So there's actually a lot of settings. Well, it'll actually also identify all the global things. And so, okay, hey, there's the namespace old school way, which I mentioned was not a good idea because it's still global, but it identifies those things for you. And there's lots of checkboxes if you want to change some of the settings. But that's a great tool to run against. And Douglas Crockford wrote JavaScript the good parts, which identifies a lot of these things. If you don't like to read, he actually did a video series on Yahoo called Crockford on JavaScript. And there's 4 parts, and he explains most of his book and some of these principles more in depth. And there's lots of good stuff on Script Junkies if you want to look more about closures or prototypes, which we barely touched on. Oh, and Julian wrote a great series on his blog, JavaScript for C# programmers, that I would recommend. Last shameless plug, this talk I'm trying to get to speak at Mix 11, so if you could vote for me, I'd appreciate it. It's a bit.ly link, etm-mix11-vote. And if there are any questions, I will try to answer some of them.
Hey Elijah, we've been answering some questions behind the scenes, but let's see. From Mark, how do you change the behavior so that you're highlighting above the cursor instead of where it points? How do you stop that behavior? Oh, it looks like he's answering.
And the presentation when he clicks.
I think he was answering someone else's previous question. Let's see.
Oh.
Which was, how do you change the behavior so you're highlighting above instead of where it points? How do you stop that behavior? Does that make sense to you?
I'm not sure where I was doing that. Was it on a code example? Let's see. How do you change behavior so that you're highlighting above the cursor instead of below? I'm not sure. I'm not sure what that
Elijah,
means.
it's Julian here. Um, Basically, Mark was asking, oh no, somebody else was asking earlier on about a particular behavior inside the slide deck application that you're using. It seems
Oh,
that the highlighting was occurring above the cursor rather than at the cursor. I can't
oh,
say I noticed it myself, and I basically asked for some more information about what the attendee was actually seeing. So maybe Mark has been answering that question.
okay. Yeah, I'm using, um, for those of you who don't know, I'm using something called JS Fiddle, and I use it all the time. So if any of these are code examples, if I launch it, it'll bring up a large version, jsfiddle.net. You could pick any library that you want, and you can put HTML on the top, JavaScript on the bottom, CSS, and then it will run it in the result. And so a lot of my examples, and what the cool thing about it is you could fork these, you could actually run JSLint internally, which thankfully this one's valid. But there's lots of great options. You could share this with friends. You could embed it on your blog, kind of like I'm embedding in this presentation. And so there must be something that they're doing to do that behavior. I haven't looked into it, but I would encourage you to look at JSFiddle if you haven't seen it already. It's a great way to play around with some concepts and get ideas from other people. And it's actually the
Great.
preferred way for jQuery to, if you find a bug, to try to replicate it in JSFiddle so they could try to address that. Go ahead, sorry.
No, I would thought you were done, so I was going to tell you. We
Okay.
I don't know, if you can see these questions that I think Julian was answering a lot, behind the scenes. If there's any you want to address maybe live.
Okay, let me see. Is triple equals faster? I don't know offhand, but I would think so because it doesn't have to coerce each side. Because using the double equals, it tries to be smart about it. Um, there's actually that's a good question. I could research that and for you. There's some tools for performance that I could use, but offhand, I'm not really sure. Um, the slides are not um, on the enterprise jQuery.com. But really, all the code snippets were kind of taken straight from the article series, so it will look very similar, like everything about bacon and eating and all that good stuff.
Made me
Um,
hungry.
let's see, something like C# properties. If you're talking about like properties with get and set, wait, in cross-browser JavaScript. Yeah, the way I was showing properties with JavaScript will work across any JavaScript engine. There's nothing special that you do there. Really, the problems that you get in most of JavaScript gets a bad name primarily because the DOM really stinks across browsers, and they did it differently. And there's a bunch of nuances and weird things that are different, and you have to know those things up front. And that's why jQuery really made JavaScript coding more accessible because it tries to take the brunt of all that crazy DOM stuff and make it easy. So you could focus on pure JavaScript, which mostly works the same across all browsers. Now, Douglas Crockford, in that series I told you about in that book, he recommends not using certain features of JavaScript because they're either dangerous or they could cause some weird scenarios. And so everything I showed in this presentation, are ordained, and you could use them. But there's some things like eval or in the with statement that he encourages you not to use. And if you want to do some more research on those, you can. But everything I showed should be fine. As I'm aware that if they're recording this, and it should be available, as someone asked.
Yeah, we are recording it, both the video, so we captured all of your, your slides and coding, and it will be available at tv.devexpress.com later today.
Okay.
You have a question here down at the bottom. How can I call a window.set timeout inside my method and use my instance inside the timeout function?
Well, as long as the so Windows set timeout is at the global scope, and so as long as it has access to whatever you set at that time, I guess I'd have to see how you're calling it, because there's several ways that you could do that. Feel free to email me at elijah.manor@gmail.com, and if you want to use jsfiddle.net for your example, I could help you work through that. And anyone's available to email me. Yeah, the slides I can make available. It's just your website. So, yeah, someone linked the YouTube for the. Oh, the great thing about the Douglas Crockford series, if you actually go to yahoo.com, or not yahoo.com, but wherever it's located on Yahoo, all the talks are transcripted, so you could actually see all the text. And so, because I don't necessarily want to watch an hour video over and over again, because there's like 4 or 5, so that's 5 hours of video. I'll remember a key concept, and then they've actually typed it all out, so you could actually go back to it later, and I do that quite a bit. Well, great. Thanks for having me, and appreciate for all you coming.
Awesome. Thank you, Elijah, for being here. A great webinar. And everybody, just so you know, Friday, February 4th is our final webinar this week. It's Framework Friday with XAF evangelist Gary Short on XAF view structures. Join us for a quick tour of the new and refactored views hierarchy within XAF. And a quick peek into next week. Next Monday, February 7th, our DevExpress CTO, Julian Bucknell, who you've heard a little bit, is doing a webinar on JavaScript 1. Writing JavaScript when you already know C# can seem like a piece of cake. After all, it's a C-like language, so what can go wrong? Julian starts off a series of webinars to teach you the basics of writing JavaScript. No experience is necessary apart from an understanding of C#. And this webinar will concentrate on types. And next Wednesday, February 9th, MVVM with DevExpress Charts Silverlight, how you can use MVVM concepts with the DevExpress charting platform. We have a full lineup of webinars currently scheduled through the month of March. You can check them out and register for them at devexpress.com/webinars. And again, if you missed anything from this webinar or you want to watch it later, we will have it posted on the DevExpress channel at tv.devexpress.com. Again, thank you so much, Elijah, and thank you all for being here, and thank you for choosing DevExpress.